Hey guys, welcome back to the show. I just want to give a quick mention of this app that we have. So it's called the Tenfold app. It is available on Android and iOS. And we've added a feature to the app which allows you to watch the Tenfold live show anywhere where you are in the country. It does use a little bit of data, so you can watch it. So my mom and dad have actually downloaded the app, well I hope they have, so they can actually watch me on TV tonight. Just another big thank you from Liberty. They've made this all happen, guys. So let's get on with the show, and we're going to look at a question from Bongani. Let's have a look at what the question is.
Hello Tenfold, my name is Bongani Makosonke and I am currently in grade 12 at Parkies. So I've been revising for the junior exams and I've been struggling with a certain problem. Please help me out. The problem is a point P, X and Y moves so that the difference between the squares of its distance from the points A, -3 and 5, and B, 2 and 6 is equal to 8. Determine the equation of the locus of P. Guys, what's locus? Please help. Here's the question.
All right, okay, thanks for that question. Let's have a look at the question first, and then I'm going to start answering some questions based on what you guys might have at home. So the question reads as follows. It says here that a point P, X, and Y moves so that the difference between the squares of its distance from the 2 points A, which is 3 and 5, and B is 2 and 6, is equal to 8. And they're asking us to determine the equation of the locus of P. Okay, guys, so when we have a locus, it's not a locus that will be flying in your backyard or in some crops. What a locus is, it's a path that a point traces with respect to other points on a Cartesian plane. So to give you an idea, one of the most simplest locus that we can have is that a point equidistant from another point forms a circle. And that locus, well, the locus will then be called a circle. Okay, so that is what a locus means. Now, in our question, we got 2 points, and we got another point that moves, and the difference between the squares from those 2 points must equal to 8. So let me show you how we're going to go about doing this. I'm going to start by drawing a diagram for us, just so you can have an idea of what it is we need to do. So on my Cartesian plane, I'm going to have the point A, which is -3 and 5. So -3 and 5 will be somewhere about there. I'm going to label that point A. And I'm going to label my other point, point B, which is 2 and 6. So that's about 2 and up there 6. It's not an accurate diagram. It's not necessary to be accurate because we are going to have some things to find. The other part is point P. Okay, so I don't know where point P is, guys. Point P is given to us as X and Y. So that can be anywhere on my Cartesian plane. But what I do have is information surrounding this point with respect to the other 2 points. So what I can do is, I can say anywhere on my Cartesian plane, I'm going to put it over here, point X and point Y. Now let's go back and read some of the other information that they gave us. It says that this point moves so that the difference between the squares of its distance from these 2 points. So guys, I need some sort of distance on my diagram. It says that I have a distance from point P to other 2 points, and if I square those distances and I subtract them, I then get a value of 8. So that's what I'm going to do right now on my diagram. I'm going to have a distance for PB and another distance for AP. Now, if I square these 2 distances and subtract them, I must get an answer of 8. So guys, what happens is you see this question in the exam, you're like, oh damn, what do I do? Okay? Use the information that's been given to you and fill in everything that you have. So right now, I've been told that I need a square distance and I need to equate it to 8. So that's going to be my first part that I'm going to do. I'm going to say then that AP, and it's going to be a distance AP. If I square it, and let me just see, I'm looking for the difference. So I need to subtract it from my other distance, which is PB. And that's going to be a distance PB squared. And they say that must give me an answer of 8. Okay, so I've got one equation. That equation comes from the information that's been given to me in my question. That's my very first part to try and solve in for my equation of my locus. What I need to do now is fill in AP and PB, and I need to square them. So what I'm going to do is I'm going to find AP. So let me have a look at how I'm going to do that. My distance AP, I'm going to use my distance formula. So I'm going to say AP, and I'm already going to square it so I can plug it back into there. I'm going to say AP squared is equal to x minus -3, which is then going to become x plus 3, all squared. And it's my distance formula, so I'm going to add the difference on my other two coordinates, which is going to be y minus 5, all squared. Okay, I'm going to keep that as is for now. Actually, no, let me multiply this out. I'm going to end up with x squared plus 6x plus 9 plus y squared minus 10y plus 25. And I'm going to call this equation number 1. So we've now found a distance for AP. We're now going to do the exact same thing for PB. So if I find PB squared, or BP squared, doesn't really matter, I'm going to have that it's going to be 2 and 6 on my two values. So I'm going to have x minus 2 all squared plus y minus 6 all squared. And if I multiply this out, I'm left with x squared minus 4x plus 4 plus y squared minus 12y plus 36. And I'm going to call this equation number 2. Okay guys, so at this point we've got two equations. We know exactly what they need to be equal to when we subtract them. So what I'm going to do now, and this is going to get quite long, I'm going to take these two equations, substitute it into my first equation, and then see if we can simplify some values. So this is where it gets a little bit long. So I'm going to have then that my first equation is going to be x squared plus 6x plus 9 plus y squared minus 10y plus 25. Oh, and I think I'm going to run out of space over here, but that's fine. I'm going to subtract it, so that means all of these signs in front are then going to change. I'm going to have minus x squared plus 4x minus 4 minus y squared plus 12y. And I've just run out of space over here. I'm going to have minus 36. And if we have a look at my first equation, these two subtracted from one another give me a value of 8. So what I'm going to do is I'm then going to equate this whole thing here to 8. Now let's do a bit of cancellation, guys. I'm going to have x squared and x squared. That's going to cancel. As well as y squared and y squared. That's also going to cancel. So if I look at this piece over here, I'm going to have 6x plus 4x. That's going to get me 10x. I'm then going to have 9 plus 25. That gets me 34. Minus 4 gets me 30. And minus 36 is then going to get me negative 6. And then I'm going to have 10y plus 12y, or negative 10y plus 12y. And that's going to get me plus 2y. And this is all equated to 8. Okay, so if I have to just do a little substitution over here, or a little bit of simplifying, I'm going to get that 2y is equal to, it'll be 8 plus 6, which then gets me 14, and that'll be minus 10x. And if I divide through by 2, I get y is equal to negative 5x plus 7. And that there is the equation of my locus. Okay guys, so what that means is I've just found a line now, and that line is going to be the locus, where if I subtract the squares of those distances, I'm always going to get a value of 8. So thanks for that question. It's nice working on some terminology over here, and it does help you when you start getting into your final exams. Guys, we're going to go to a quick career video, so stay tuned and hope you've been enjoying the show.
I'm Barry Baumgart. I'm a registered physiotherapist. Been practicing for 15 years now. specializing in orthopedics and sports injuries. So physiotherapists are trained to assess and treat a various range of pain syndromes or injuries. We do so with detailed physical examination and then a variety of treatment techniques. So the thing I love most about my job is meeting different people. So different people with different backgrounds, different problems to solve, and a variety of new challenges day to day. So I basically problem solve their issue to try and get them back on track and try and get them well again. So maths and science is important in my work on a daily basis because we're constantly using the measurement of angles, the measurement of loads in various joints at certain junctions and the tension held in muscles as part of our evaluation. My understanding of analytical geometry is measuring forces in the form of vectors, and that is applied directly in how we evaluate movement at certain joints and the load that's taking place there. We use those readings to help with our corrective and rehabilitative exercises that we prescribe to correct the biomechanics around a joint. I think that the most fascinating part about my job is the study and functional understanding of anatomy and physiology. So it's seeing how the body's been made, how it's been created, understanding what can go wrong with it, but also understanding how it can be healed. And so it is amazing to just consider everything that makes us human beings. So how I see my physiotherapy career blending very well with other things I'm passionate about is that I've worked a lot with break dancers, myself being one, in trying to help them and other dancers to achieve optimum levels of performance. And I've just seen how the physiotherapy knowledge of science has blended perfectly with art to have given dancers the best approach to injury prevention training methods. So what influenced me to choose physiotherapy as a career was probably realizing that I wanted to work with people. So I wanted to interact and work to help people. My dad is a medical doctor, so there was a strong medical influence, but I knew I did not want to handle blood and guts and gore, but I did want to help people. So being active, I thought I'd like to work with people who are keen to get back into activity, back to normal life. The type of person who's suited to be a physio, I think, is somebody who does love people, love being around people, interacting with people, and who has a certain patience to hear other people's burdens and aim to help them be free of it. Yeah, people's person would be the best fit for physio.
Hey guys, how's it going? I hope you enjoyed that career video. If you've just joined us, this is the Tenfold Live Show, proudly brought to you by Liberty. This is the last show for analytical geometry this week, and we'll be dealing with grade 12 analytical geometry. Next week we're going to go back. And look at some exam preparation that is going to help you for your mid-year exams. Right now we've got a question based on analytical geometry from Luanda. Let's have a look at what Luanda has to say.
Hi Tenfold, my name is Luanda and I'm from Durban. Well, as you know, we're currently busy with the June exams and I've been having problems with this maths problem. Please help me.
Alright guys, it's a typical exam question that you're going to get when you start writing your final exams, or if you write a cycle test or anything like that. The question reads as follows. It says, determine the equation of the straight line passing through the point 2 and 4 and parallel to the line with the equation 4x minus 3y plus 5 is equal to 0. Okay guys, so there's a couple of key words that we need to work on over there. The first one is parallel. Now, when it comes to analytical geometry, if lines are parallel, you know that they run next to each other and they're never going to intersect with one another. In order for that to happen, the gradients of those lines need to be exactly the same. The other bit of information that we got is that it goes through a point. Now, that point doesn't lie on the line that was given to us. So we want to find what is the line that goes through that point and is parallel to my other line. So the first thing that we're going to do is we're going to have that my gradient of the line that we're looking for, I'm going to call it M1, is going to be equal to my gradient of my second line. Now you can see up over here, my equation is not in standard form. So we first got to put this into standard form. So we're going to have that 4x minus 3y plus 5 is equal to 0. So if I have to put this in standard form, I need to make y the subject of my formula. So to do that, I'm going to keep negative 3y on my left-hand side. I'm going to subtract 5 from both sides, as well as negative 4x. And I'm then going to divide through by negative 3. So I'm going to have y is equal to, that's going to be 4 over 3x. And 5 divided by 3, it's negative 5 divided by negative 3. So it's going to be positive 5 over 3. So in this form, guys, we're now in my standard form. I can see that I've got my standard form, which is y equals to mx plus c. And m is my gradient of that line which we've been given to us. So I need to know then, well, I know already that my gradient of my other line is going to be equal to 4 over 3. So I can then say m is equal to 4 over 3. And that means then that my gradient on my second line, m2, is going to then also equal to 4 over 3. So guys, now the next part now, it says that, well, it is parallel, but it goes through the point 2 and 4. Okay, guys, so I know that my line's gradient now is 4 over 3, and I've also got another point which it goes through. I need to then find the equation of that line. Now there's many ways to do this. If I have my gradient, I can substitute in those 2 points. Or what I'm going to do now is I'm going to show you a little bit of collinearity. So what collinearity is, it means that because I have a straight line, my gradient from one point to some other point on that line is equal throughout. So my gradients throughout my line, because it is straight, I have the same gradient at every point on that line. So I'm going to use this fact to then show you how another method to find the equation of a straight line. So I'm going to say, what I've just said over here is I've got some line and I've got some point which was given to me as 2 and 4. And I'm then going to have some other point x and y. And I know that the gradient between these 2 points must be 4 over 3. So I'm going to use this fact to now show you another method of finding an equation of a straight line. So my gradient formula tells me that I'm going to use m2 because that's the one that I'm looking for. m2 is equal to y2 minus y1 divided by x2 minus x1. And I've been given the points which we're looking for. I know that my gradient is 4 over 3, so I'm going to substitute that in. And I'm then going to also have my y coordinates. I'm going to have that as 4 minus y. And I'm going to have my x2 coordinate as 2 minus x. Okay, guys, so what I have at the moment, I've now written down my formula relating these 2 gradients together. And if I just do some quick cross multiplication or solving or making y the subject of the formula, I'm then going to end up with my equation of my straight line. So if I have to do that, if I cross multiply over here quickly, that's going to be the easiest way to do it. I'm going to be left with 8 minus 4x. And then if I multiply through by 3, 3 times 4 is going to give me 12. And then I'm going to have negative 3y. Okay, so at this point in time, I have this scenario. I need to then make y the subject of the formula because I like to keep my equations of straight lines in y equals mx plus c form, the standard form. So to do this, I'm then just going to do is going to be 8 or 12 minus 8. I'm going to have then 12 minus 8 is equal to, actually, no, let me do this another way. Okay, let me keep all my variables on the one side so I don't confuse you guys. I'm going to have 8 minus 12 is equal to negative 3y plus 4x. So 8 minus 12, that's going to get me negative 4. I'm then going to subtract 4x, negative 4x, and that's going to equal to negative 3y. I'm then going to have the following. If I divide through by 3, or negative 3 rather, I'm going to get my equation in this format. So I'm going to have then 4 over 3, and that's going to be negative 4 divided by negative 3 is positive 4 over 3x, and that's equal to y. And I'm just going to move that to the other side, makes my life a little bit easier. I'm going to have y is equal to 4 over 3x plus 4 over 3. And let's have a look over here. If you see over here, my gradient that I'm looking for is 4 over 3, so I know that I've done this correctly. Okay guys, so at this point, I've got my gradients that are exactly the same. That means the lines are parallel. And I have a y-intercept that I found also to be 4 over 3. Now, my y-intercept is dependent on my point that I get given in my question. If I get given a different point, my y-intercept is then going to change. So guys, before we go to an ad break, I just want to mention that we have this app. It is available on Android and iOS. And guys, I really love this app. I can't stop talking enough about this app. There's assessments on this app which help you guys before you write a cycle test, and it's going to be especially crucial now before you go into your exam preparation end of the month or next month, and that's really going to help you. All these assessments, they're all multiple choice, and you can click on them. They can then give you information where you're going wrong, and they can give you a memo of where it is. So to download this app, you go to your Play Store, iOS or Android, and you type in Tenfold Education. It's the Tenfold app, and it's a free download. It does take a little bit of data to use the app, but we're going to start giving out vast data, which, as you mentioned on, if you look at the ads, vast data, guys, it's a little voucher that you buy. You go to areas where there's hotspots, and you type in your little voucher code, and you then link up to that hotspot Wi-Fi, and then after that you can use the Wi-Fi for however long that voucher tells you to do. So guys, have a look at the app. It really is a great app. We're going to take a quick break now, and we're going to be back with some more questions on analytical geometry. Guys, stay tuned.